Hi guys, my name is Bas and welcome to another SPSS tutorial on my YouTube channel. Today we're gonna have a look at binary logistic regression, which means that the dependent variable of your experiment has a binary outcome, which means that it is either 0 or 1. And the dataset which we're gonna look at today is about whether you passed a statistics exam, with a 1 being that you passed and a 0 being that you didn't pass, and the amount of hours you've studied for the test, and if you've taken a exam training with me, Baspss. And what we can see that, for example, this respondent number 1 didn't follow my exam training. He or she studied for 13 hours, and he or she passed the test. While, for example, respondent number 24 took my exam course, because there's one, they took the training. He or she spent 6 hours on studying, and he or she didn't pass the test. And I've made up this data set. It's not real data. I've just made it up. What we're gonna do today is to find out whether there is a significant relationship between both hours and whether you passed it, and the training, and whether you passed it. And being you passed is the dependent variable. Being whether you took the training or not is a categorical independent variable. And the amount of hours you studied is a continuous independent variable. And what we're first going to do is a short cross steps. So we're going to go to Analyze, Descriptive Statistics, Cross Steps. Then we select the two binary variables. So whether you took the training or not, and whether you passed or not. Exact you leave as it is, and at statistics you select the chi-square, and at cells you select the observed and the expected amount of counts from the frequency. Then you press paste. Then you go to the syntax screen, you select the cross steps code, and you press the big green play button. And then if you go to the output window, we can see that if there was no relationship between the independent and the dependent variable, then the expected count of people who didn't take the training and didn't pass would be about 21, but in reality it's 28. And for example, the people who took the course but didn't pass should have been 19, but what it was in reality 12. And therefore, if you take a look at the Pearson chi-square or chi-square, we can see that the significance level is 0.003. So therefore, there is a significant relationship between whether you took the training and whether you passed the test or not. But we of course want to know what this relationship is. So we want to know the betas of this exact relationship. So you go to Analyze, Regression, and this time not linear, but you select binary logistic. The dependent variable in this case is passed, whether you passed or not, and the independent variables are hours, how many hours you studied, and training, so whether you took the training or not. Then at categorical we select training because it is a categorical variable. So I'll take it out and I'll select it again, and then you press continue. Save we don't do for now, and at options you select classification plots and Hosmer Limshow goodness of fit, and then you press continue, and then you press paste, and then you go to the syntax screen, and we select the syntax code for this logistics binary regression, and you press the big green play button. And if we then go to the output screen, you can see that there was a total number of respondents of 100. The dependent variable, so whether you passed or not, if it has a 0, it will remain a 0, and if it had a 1, it will remain a 1. But this is important, for the categorical variable codings, so in this case it was training, we marked it as a categorical coding. If training was 0, then in this analysis it will be 1, and if the training was 1, then in this analysis it will be 0. That's a bit confusing, I know, but it's just the way that SPSS operates. So first of all, we take a look at the where there's a lot of models, but we're not gonna discuss all of those today. You mostly look at the Nagelkerke R-square, which is 0.617, which means that this model explains 61.7% of the total variance in passed or not, which is, yeah, quite decent. But if you look at the Hosmer and Limshow test, it is a goodness of fit test. So to what extent your model is a good fit, and it should be above 0.05. In my case, it is not. So, but it's because I made up the data. So in your actual research, it should be above 0.05. But because I made up the data, I just put something together. It is not significant. It is significant, but you want it to be not significant. So that is a requirement if you want to take a look at the final, at the variables in the equation table, because this is the table that we care about. And if you take a look at hours, you can leave the slope as it is, because we mostly look at the beta, and the beta for hours is 2.237, which means that, and it is significant, so that means that hours has a significant influence on whether you passed or not, which is logical, because if you study more for a test, you will try to get it, you will pass it earlier. With a beta of 2.237 and a significance level of lower than 0.01. And if you take a look at training, we can see that the expected beta is 0.018, which is also significant. So if you took the training or not, also has a significant influence on whether you pass the test or not. If you would take a look at the slopes for hours, then you would see that the slope increases. So if you study more hours, then your whether you passed or not increases. While training is negative, but that's because, as I explained earlier, it has switched around the training. Categories. So a 0 became a 1 and a 1 became a 0. So in this variables in the equation table, you can see that the slope was minus 4.038, but it is, but that also means that the chance of passing became higher. But it's a bit confusing, but I hope that I explained it well now. But you have to report the betas in this case and the significance levels. So that's the video of today. This is how binary logistic regression works. For next episode, I'll discuss what is it called again? Multinomial logistics regression. But for now, this is going to be it. If this video was helpful to you, then please leave a like on this video and subscribe to this YouTube channel if you, for more statistics videos. And for now, I'll see you guys in the next episode. Ciao.